In this video, I'm going to go over how to add and subtract rational expressions. So just like adding and subtracting any type of fraction, you have to have a common denominator. So I'm going to first look for a common denominator. In the first example, I have one. And so when you have a common denominator, you're just going to add and subtract across the top, and you're going to keep your denominator the same. So I'm going to write it like this: 15x minus, and I'm going to put this expression in parentheses because I am subtracting that entire fraction. I'm going to distribute my negative sign. So now I have 15x minus 3x minus 3. They both become negative, all over 4x minus 1. And then lastly, I'm going to combine like terms. My 15x take away 3x becomes 12x minus 3, which is still over 4x minus 1. Now, just now, when you think you're done, you need to check to see if there's a GCF that you can take out. And in the top, there is. I can factor out a 3, which would leave me with 4x minus 1 over 4x minus 1. And now, my 4x minus 1s cancel out, and I'd be left with 3 as my final answer. All right, number 2 also has a common denominator. So I can add across the top, 3r plus 15 over r plus 5. I did not need parentheses this time because I don't have anything to distribute. It would be like distributing a positive 1, and that doesn't change anything. So now I'm going to see if I can take out a GCF. On the top, both terms are divisible by 3. So I'll factor out a 3. That will leave me with r plus 5. And this one also cancels. Now, I don't want you to think that they're always going to do this, because they're not always going to do anything. Every situation is unique. All right, so let me clear some of this up so it's not in the way. All right, number 3 here, we do not have a common denominator. Now, they do both have an x, so we've got that covered, but we need their coefficient to be the same. So I'm going to start thinking about multiples of 8. So 8 times 2 is 16, but 6 doesn't go into that. 8 times 3 is 24, and 6 does go into 24. So I'm going to make this fraction be over 24x by multiplying by 4, top and bottom, and I'm going to make this fraction be over 24x by multiplying by 3, top and bottom. And so now I have 28 over 24x plus 15 over 24x, and I'm going to add my numerators together. I'm just going to do 28 plus 15, and that gives me 43 over 24x. Now 43 over 24 cannot be simplified, and so we are done. All right, number 4, I have 2 over 1 minus 3 over x. Anytime you have a whole number, you're going to want to write it as something over 1. So the other fraction has a denominator of x, so I can just multiply this fraction by x, top and bottom, to make it be over x. So now I have 2x over x minus 3 over x. So now I'm ready to subtract across the top, 2x minus 3, and write it as one denominator. I'm done here. I cannot cross out those x's because 2x minus 3 is a binomial. They stay together. You cannot cross things out that are separated by subtraction or addition and then over that. So like I could do this. I could do this times 3 over x, but I can't do it when it's separated by a minus sign. All right, let's get into more exciting ones. So here I have 1 over x plus 2 and 2 over x. So I'm going to multiply top and bottom by x here. And then I am going to multiply this one by x plus 2 top and bottom. So when you have a binomial and just one term, the x, the monomial, their x, you're going to want to just take the denominator of the other one and multiply it top and bottom by the other fraction to get a common denominator. So now my common denominator is x times x plus 2. You cannot, unfortunately, look at x plus 2 and be like, oh, I'll just give this one a plus 2, because you can only change fractions by multiplication, top and bottom. You can't change them by adding. All right, so I'm going to rewrite this. I have x, 1 times x is x over x times x plus 2. And then I have 2 times x plus 2 over x times x plus 2. And I can combine across the top. So I would have x, I'm going to distribute, plus 2x plus 4 all over x times x plus 2. And then lastly, I can combine these like terms on the top. And so my final answer is going to be 3x plus 4 over x times x plus 2. Now, different teachers require different things. I have my students leave this as is because I can't factor anything out of the numerator, so nothing's going to cancel. But if this was a multiple choice exam, you might see that the bottom had been redistributed. And so that is another way you could see the answer. All right, one more example for this video. When you have two fractions and one is a trinomial like this first one here, I'm going to start by trying to factor that. And I can. Now, as I often tell my students, use the problem to do the problem. When you glance over here and see x minus 6, think to yourself, could that be a factor of x squared minus x minus 30? So negative 6 times positive 5 would be negative 30. And if I add them together, I get that negative 1 term in the middle, which I need, that negative 1x. So those two are my factors. So now that I have this, I can multiply the other fraction by x plus 5 top and bottom to get a common denominator. So now I have 3x plus 5 times x plus 5 on the top all over x minus 6, x plus 5 on the bottom. So now I'm ready to write this as one fraction to show that I'm going to subtract. So I've got 3x minus, I'm going to open up a parenthesis. When you have two fractions that you're subtracting this entire fraction, that entire numerator. And so when I distribute, I'm going to have to also distribute the negative sign. So I'm going to leave it in a parenthesis while I just distribute those two parentheses. So I've got 3x times x is 3x squared. 3x times 5 is 15x. 5 times x is 5x. And 5 times 5 is 25. All over x minus 6, x plus 5. All right, so then I'm going to write this. Let me just white out this. All right, so now I'm going to distribute the negative sign. There's a lot of things you could do here. Like you can go ahead and imagine these two together. That might help. I'll go ahead and do that to save steps. But I have 3x minus 3x squared. Those two yellow highlighted terms would become 20x. So I would be distributing the negative to those as well, making them negative 20x. And then the negative goes to the 25 and makes it negative 25. Again, all over x minus 6 times x plus 5. And then I'm going to combine my any like terms. So I've got a 3x and a negative 20x. And so lastly, I would have negative 3x squared minus 17x minus 25 over x minus 6 times x plus 5. Now again, this is where I tell my students, I want them to try to factor the top, but this one is not factorable. And so I know that there's not going to be anything that cancels. So I would try to factor the top, but then if this was multiple choice, the only difference is you might see the denominator having been redistributed. And that would have just looked like the very beginning. So that would have been x squared minus x minus 30. So you might see it written back distributed as well.